Good morning. This is Ahed from Logos Institute, and today I will be explaining the exponent laws, and I will be giving you a couple of examples. Some difficult, some easy to practice. Alright, so the first exponent law is called the law of multiplication. And here, if we have a certain base a to the power of m multiplied by base a to the power n, that is equal to base a to the power m plus n. So we add the exponents in this law. To give you an example, let's say we have 4 to the power of 6 multiplied by 4 to the power of 2. That will be equal to 4 to the power of 6 plus 2, which is 4 to the power of 8. X to the power square times x to the power of negative 5. So that will be x to the power 2 plus negative 5, which is x to the power 2 minus 5, or x to the power of negative 3. We'll talk about negative exponents a little bit later. The second law of exponents is called the law of division. So you have base a to the power m divided by base a to the power of n, so that is equal to base a of m minus n. An example of that would be 4 to the power of 6 divided by 4 to the power of 2. That will be equal to 4 to the power of 6 minus 2, or 4 to the power of 4. The third law, the law of power of exponents. So here we have base a to the power of m to the exponent n. So something, a base that has a power of m, all of that is to the exponent n. In this case, the answer will be a to the power of m, the first exponent, times n, the second exponent to which the first term is raised to. An example of that would be 3 to the power of 2 times, or to the power of 3. So that'll be 3 to the power of 2 times 3, or 3 to the power of 6. Another example, x squared to the power of 5, that will be x to the power of 2 times 5, or 10. The fourth law is a law of a power of a product. So here we have a product AB. Notice that it is not a plus b or a minus b. So the AB is one term composed of two variables, a and b. This product is to the power of m. The power m applies to each component of the product. So the m applies to the a and the m applies to the b. So ab to the power m is a to the power of m times b to the power of m. So an example of that would be xyz, or z if you don't like the z, to the power of 3 to rhyme. So the 3 applies to x and y and z. So that becomes x cubed, y cubed, and z or z cubed. Okay. Next law is the law of a power of a quotient. So in the same way that the exponent m applies to both components of a product, it applies to both components of a quotient. So a to the power of m divided by a to the power of n. Oh, mistake here, that is m, the same exponent. So an example of that would be 1/2 to the power of 3. So 1 to the power of 3 over 2 to the power of 3, or 1/8. Next law is the law of the zero exponent. So anything to the power of 0 is equal to 1, assuming that a, the base, does not equal to 0. An example of that would be 3xy squared z to the power of 4 divided by 1985, my birth year, to the power of 0. When I see that, I'm very happy because I know whatever is in here to the power of 0 will equal to 1. And the 0 simplifies the life. Next law is the law of negative exponent. So base a to the power of negative m is equal to 1 over a to the power of m. So if we want to get rid of the negative exponent, we have to find the reciprocal of the fraction. So whenever we switch the fraction or from the reciprocal, the exponent sign will change. In the same way, 1 over a to the negative m, if we want to make the exponent positive, we have to switch it from denominator to numerator. So this becomes a to the power of m over 1. So we found the reciprocal of the fraction, to change the sign of the exponent. So an example of that would be 1 over x to the minus 5. Negative exponents are ugly and they're not nice and sightly in an answer, so we're just going to switch it. We're going to find a reciprocal of the fraction. So x to the power of 5 over 1, or just x to the power of 5. So here we're going to do a few tougher examples so we can practice solving problems with exponents. So here we have 3ab cubed times 10a to the power 4b squared divided by 15a squared b to the power 6. So what I'd like to do normally is to start with the numerator, or whatever is tougher. So here we start with the numerator. We're going to multiply these two terms. So we start with the constants. So 3 times 10 is 30. A to the power of 1 times a to the power of 4. So we're going to apply the first law. A to the power of 1 plus 4. And b cubed times b squared. Again, the law of multiplication applies here. It's b to the power 3 plus 2. And that will be divided by 15 a squared b to the power 6. So again, we did not do anything to the denominator yet. Now, 30. A to the power of 1 plus 4 is a to the power of 5. And a to the power of, b to the power of 3 plus 2, b to the 5. That is divided by 15 a squared b to the 6. So, here we have 30 divided by 15, which is 2. A to the power of 5 divided by a to the power of 2. So a to the power of 5 minus 2. Same for the b to the 5 divided by b to the 6. So b to the 5 minus 6. 2, a to the 3, b to the negative 1. Negative exponents are unsightly, so we want to get rid of that from the answer. So here we have a denominator of 1. So there's only 1 in the denominator. But the b, because it has a negative exponent, is going to have to join the 1 on the denominator so that we can switch the sign of the exponents. So here we leave the 2a cubed in the numerator, and we're going to bring the b to the negative 1 to the denominator. So it becomes b to the positive 1. But again, every number is to the positive 1. So we're going to remove it from the answer because it is assumed. So the answer is 2a cubed over b. The next example, 4x to the negative 3, y to the 4 divided by 8x squared, y to the negative 2. All of that is to the negative 2. Again, there are different ways to solve in this question, but I would like first to get rid of the negative exponent here. And to get rid of the negative, I would have to find a reciprocal of the fraction. So I'm going to write the reciprocal of this fraction in order to switch the sign of the negative 2. So 8x squared y negative 2 divided by 4x to the negative 3 y to the power 4. So I did not change anything here. I just switched the numerator and the denominator. Squared. Next step. Let's solve what's on the inside. 8 over 4 is 2. X to the power 2 minus x to the power divided by x to the power negative 3 is x to the power of 2 minus 3. And y to the negative 2 minus 4. And all that is still to the exponent 2 to the power of 2. So 2x to to the power of 2 minus minus 3 is 2 plus 3, which is 5. Y to the power of negative 6. And all that is to the power of 2. So now the 2 is going to apply to each term in this product, or each component of the product. So 2 squared is 4. 2 to the power, x to the power of 5 to the power of 2 is x to the power of 10. Y to the negative 6 to the power of 2 is y to the negative 12. So same thing here. Having a negative exponent is unsightly in an answer. So we're going to bring the y to the negative 12 to the denominator to make its exponent positive. So this becomes y to the 12. Is there anything else we can do to simplify this fraction? No. We cannot apply the law of division because these are two different variables, x and y. So we cannot do that. So this is the answer. And I hope this video helped you guys. Next video is going to be about rational exponents and how to deal with those. Have a nice day. Bye-bye.